switching technologies, we discussed about VLAN, right? The VLAN
Yes.
multi-layer switching, all these configurations, is it working?
Sir, one doubt, sir.
Okay. Which one?
Can you explain VLAN ID, sir?
ID is nothing but just an identifier you have. Identifier in the
Okay.
sense you have the, let me just load the project. Okay, so these are identifiers, nothing else. Okay, VLAN ID is simply to represent the broadcast domain what we are creating. Broadcast domain means when you are dividing this single broadcast domain, right? The single broadcast domain when you are dividing, then you are creating those small broadcast domains, right? Yes or no?
Yes. Yes.
How do you identify these small broadcast domains? Without an ID, is it possible to identify?
No, sir.
This is what identifier. All these are
Okay.
identifiers. VLAN 1, 1000, 2005. These are basically default identifiers for like what VLANs in the switch. But if we want to create our VLAN for all these departments, this is when we are using these identifiers. You can use any number in between this range to identify the broadcast domains what you are creating within your multi-layer switch or your layer 2 switch. That's it. This is just
Sir,
an identifier.
sir, is it necessary to use the interface in 194.1.254, or
This
we can use?
is this is necessary when you are doing interval and outing.
Okay.
This interface is only required when you are using interval and outing. Means when you need to communicate from VLAN 200 to 300. This is when it is necessary. If you
Okay.
don't want to communicate from VLAN 200 to 300, then you don't need this interface. Okay. When you don't
For
want to
that IP,
communicate,
for that IP, we can use anything, or this IP only.
IP address I have taken, for example, this. You can take any IP.
Okay.
Okay. It's
Okay.
up to you. Basically, in the company, these IPs are given to you by your engineers. Okay, senior engineers, they will give you what IP address you have to give to sales department, finance department. They will tell you. Okay, but in this particular example, we are using 194 and 195 just for demonstration purpose. Understood?
And the default gateway will be this one, na, sir?
The
Dot
default
254.
gateway always will be the layer 3 VLAN interface IP address for that VLAN. So for VLAN 200 machine, the VLAN 200 layer 3 VLAN interface IP. And for VLAN 300,
Can
this is what you are having.
Okay.
you hear me, sir?
Tell me.
Your voice is not coming clearly, sir.
Voice is not coming clearly.
Yes, sir. I think some issue
Everyone
from
is
your
facing
side.
the issue.
I think some issue from your side, sir.
Okay. Everyone else
And
is facing the same issue.
you are audible to me, sir.
Yeah.
Audible, sir. Audible.
All of you can hear me properly.
Yes, sir.
Yes, sir.
Yes, sir.
Then Vikram, just rejoin the session, I guess. Okay, so understood this why we are creating layer 3 VLAN interface.
Yes.
This is for inter-VLAN routing. Okay, we need to perform routing, and to perform routing, gateway is required for every single VLAN 200, 300 machines. We are using the VLAN 200, 300 IP address as a gateway address, and this is where exactly your multi-layer switch it needs to be activated with IP routing command to perform routing. And that is pretty much it, the configuration. Very simple configuration you have in terms of inter-VLAN routing. Just create the layer 3 VLAN interface and activate the IP routing within your multi-layer switch so that the multi-layer switch can build the routing table and can perform routing. Whenever any packet comes from VLAN 200, it performs routing by the layer 3 VLAN interface to the other VLAN. That's it. Okay, so everyone is clear on this concept, correct? The
Yes.
multi-layer switch with DSCP, the layer 3 routing with multi-layer switch and the router configuration is clear, right?
Yes. Yes, sir.
So now we are moving on to the next concept. This is our VTP. What exactly we are discussing now? The VLAN trunking protocol. First of all, what is it? Yesterday I have shown you one topology, right? In the companies, how exactly your switching network it is built, where we have multiple switches connected to servers, we have one administrator system, we have department system connected to multiple switches. Remember that topology?
Yes, sir.
Yes, sir.
This is the same type of environment what we are having today also. We don't have like what admin system over here, but the rest of the things we are having the same. Uh, and this is the most common type of environment. Is the most common type of switching network what you are going to see in the organization, where we have multiple switches getting connected with each other, and we have VLANs, okay, getting created in multiple switches and machines. They reside in a specific VLAN, and their communication is divided using the broadcast domains. This is the most common type of switching network of every single organization. The thing over here is when we create VLAN, if I show you the configuration, if I am creating the VLAN, then this is the way we are creating the VLAN. This is the way. We say VLAN command, and after that the VLAN ID, then we are giving it a name to that VLAN so that we can identify that VLAN using the name, and we're saying it. This is how you create a VLAN within your multi-layer switch. In other words, you are creating a broadcast domain within your multi-layer switch. This way of creating VLAN in your multi-layer switch or a layer 2 switch, it basically consumes time. When the number of VLANs are less in number, we are right now having only 2 VLANs which we are creating. So it will not be taking time, but if the number of VLANs is around 50, if we have 50 number of VLANs which we need to create to all these switches, then obviously it will be consuming time because we'll be creating the VLAN using this approach, VLAN ID name, etc. All this. So the thing over here is how do you minimize the time? How do you reduce the time consumption which is taken in terms of creating the VLANs in your switches? So there is a dynamic process by which exactly the same thing, okay, can be done. Means dynamically you can create the VLANs across your multiple switches. and that process is called VTP. When you create your VLANs using VTP, significant amount of time is saved. Significant amount of time consumption is reduced. So in the organization, always we are looking for ways to dynamically create the VLANs. But the thing over here is, if you are using BTP, then all the switches what you are having over here, all the switches, it must be Cisco switches. This is what exactly is the requirement. If all the switches what you are using in your organization is Cisco, at, at the time only you can basically use BTP. Okay. BTP is basically stands for VLAN Trunking Protocol. And we are using it to create VLANs across multiple switches dynamically. Automated process to create your VLANs across multiple switches. What exactly we do is we create all the VLANs. So all 50 VLANs we create in one switch. Okay, create all the VLANs in one switch. And all of the switches, they basically get this 50 VLANs informations automatically, dynamically via VTP. This is coming over here as a time saver because of the fact that you don't need to go to this switch. You don't need to go to this switch and this switch to create all the 50 billion seconds, because that is the same means repetitive configuration what you are doing on these two switches as well. Okay, which consumes time. So creating all the VLANs in one switch and replicating all those VLAN informations to multiple switches. This is what exactly we're talking about in VT. So if we understand our topology, okay, if we see our topology, the topology basically consists of three VLANs we are having. VLAN number 750, we were seeing over here. This is your VLAN number 750, which belongs to tech department. Our VLAN number 550, which belongs to sales department, and our VLAN 650, which belongs to HR department. And these three VLANs were basically creating dynamically. So whether it is 3 VLANs or 300 VLANs, it doesn't matter, because the process is dynamic. In one switch, you create all the VLANs, no matter how many number of VLANs you want to create. You create it in one switch, and all of the switches, they also automatically get this information. Now, in this topology, we are having three switches: switch number 1, switch number 2, and switch number 3. Okay. As you can see that we have our server 0 and server 1 is connected to switch 1. Our laptop 0 and laptop 1 connected to switch 3. And PC 0, PC 1 is connected to switch number 2. And all these links, basically, which is connecting all the switches, all these links are basically considered as trunk link. Okay, they're configured as trunk link because this is one of the requirements of BTP. BTP always works when the links between switches are configured as trunk links, otherwise not. So it is a general guideline in terms of trunk configurations that when you are connecting multiple switches with each other, okay, or when you are connecting one switch to another switch, the link between those two switches or multiple switches, it must be configured as a trunk link. Because we need to send multiple VLANs informations. As you can see in our topology, we have three VLANs informations. But we need to be sending via one link. Okay. So trunk link is mandatory. Without trunk link, your BTP will not be working. So BTP always works with the concept of domain, everyone. All these switches, they will come in one group. They will come in a particular group. This is what we are calling domain. And in this domain, always we have a server, we have a transparent, and we have a client. These are the three modes of VTP in which exactly you can dynamically create your VLANs in switches. We have a server switch, we have a transparent switch, we have a client switch in VTP. So when we are talking about creating VLANs dynamically in a domain environment of VTP, this is the packet which exactly is being used to exchange VLAN information with other switches. This is the packet which is exchanged in the domain by the server switch. Okay, it is getting generated. Always remember that the update packet always is generated by the server. So whichever switch is working in the server mode of VTP, it basically generates this packet, and this packet getting sent to the domain, and all of the switches they collect informations from this particular update packet. Okay, because this update packet contains VLAN information. So whatever number of VLANs we are creating on the server switch, it is basically there in the update packet, and all of the switches they get all the VLAN informations from the update packet itself. It is similar like your routing update. Okay, it means routing informations getting shared with other routers, and like what all the other routers are updating their routing table from their update packet. Always like what the similar concept is there. Over here we have VTP update packet. So since it is an packet, what is getting exchanged in a domain environment, always we are securing it with a password. Means any switch who has configured, okay, or who has been configured with this password can open this packet and can see what VLAN information is there inside this packet. Okay. Any switch who doesn't have the password, they cannot open this packet. Okay, so it is basically just think of it like it is locked. This update packet is locked with the password. Anyone who is having the password, they can basically open this packet and they can see what VLAN information is there in the packet, and they can update their VLAN database, because every single switch they maintain a VLAN database within itself. Whatever number of VLANs we are creating, all those VLANs informations are available in the VLAN database. And this is the VLAN database what exactly every single switch maintains. Okay. So what exactly are these modes? We need to understand what these modes are. So mode is explained over here. So server mode basically can create, delete, modify VLAN information globally. Globally means in the entire domain. Okay, in the entire VTP domain. In the entire VTP domain, a server switch can create, modify means changing, okay, VLAN information, and delete VLANs. Okay, if you don't want any VLAN, you can simply just delete it. And this informations, okay, all the informations of your server switch, it is basically acceptable in the entire domain. Means no matter how many number of switches you have in the domain, all of them they will be updating, okay, their VLAN database informations from this update packet, because this is the packet which is used to share VLAN information with other switches. So server, just think of it like server is having the full capacity, the full privileges to create a VLAN, to change the VLAN information, to delete the VLAN itself. In the inter domain, it is getting like what applicable. Okay. So whatever we do on the server switch, it gets applicable in the entire domain. That is what we are saying globally. Globally means in the entire domain, it is getting accepted. Okay. Transparent switch also does the same thing. Means like a server, it also can create, it can also modify, it can also delete VLAN information, but it is basically doing it from the perspective of the local switch itself. Means whatever exactly we are doing in the transparent switch, as you can see that this one is transparent. Means if I create one VLAN, let's say VLAN number 100 in a transparent switch, then this VLAN information, it will be available in this particular switch only. It will not be available in this switch server or in this client switch. Okay. So VLAN 100 informations, it will be available to transparent switch only because we are creating it manually. Transparent switch configuration is all about manual configuration. You do every single VLAN configurations manually, and whatever you do, the configuration, it only resides in transparent switch only, and it is not sent by the BTP update packet to other switches, because transparent switches, they cannot generate this update packet. Okay, this update packet is only generated by the server switch. Okay, and if a particular switch cannot generate this update packet, that means what? The VLAN information also we are not getting it. The server switch is having the full power in order to generate the update packet, and this update packet gets available into the BTP domain, and whichever switches are available, they collect that information and they basically do the VLAN database update. The thing is, if we are talking about a transparent switch doesn't do any update from the BTP update packet. So every single transparent switches VLAN database information, it is not getting updated from the BTP update packet. Okay. Because every single configuration what we do in a transparent switch, always it is manual configuration. We have to do it manually. You have to define every single VLAN. Nothing is going dynamically in a transparent switch. But if we are talking about a client switch cannot create, cannot modify, cannot delete any VLAN information. As the name itself is client, so you can basically get the idea that what exactly this switch can do. This switch, which is working in the client mode, it is solely dependent on the server switch to get this VLAN information. So whenever BTP update packet is getting sent, BTP update, it is getting sent to the domain. Then this particular client switch collects this information, this update packet from the domain, and it updates its VLAN database. Okay. So client basically solely dependent on the server switch to get the VLAN information, what we are creating over there. And the VLAN database informations of the client switch automatically gets updated from the BTP update packet. Okay. So if you want to create VLANs across 3 switches dynamically, then what exactly you can do? You can make one switch as a server switch, and you can make these 2 remaining switches as client switch. Because if you are using a transparent switch, then you have to do manual configuration. But if you are using 2 client switches, then simply just configure all the VLANs in the server, and all these 2 other switches will get that VLAN information automatically from the BTP update packet. So normally in standard implementation of BTP, what exactly we do is we make one server switch and we make the rest of the switches as client switches. In this way, whatever we configure on the server, automatically it gets updated to all the client machines. And but we don't have to go to a specific switch, and we don't have to do any manual configuration over there. This is coming over here as a benefit. So configuration wise, there are certain requirements to configure BTP, and those requirements are basically given over here. The first requirement is all interswitch links must be configured as trunk links. When we refer interswitch links, this simply means that the link between these two switches, they must be configured as trunk links because our update packet contains multiple VLAN informations which we need to be sending via this single links to other switches. That is why exactly it needs to be configured as trunk. And the second thing is the domain name and password must be identical. Okay, means all the switches, all the switches, they must be configured with the same domain name, same domain, and they must be configured with same password as well. So if I am having three switches, I will configure the same domain name across all the three switches. If I'm having around 10 switches, let's say you have 10 switches, then all the 10 switches will be configured with the same domain with the same password. Okay. Because if the domain name is different, then VTP update packet you cannot process it. The switch which doesn't belong to the same domain of your server, for example, then that particular switch cannot process the VTP update information. So in order to understand the VLAN information which contains in a packet, in order to open a VTP update packet, always the domain name and the password, it must be identical, regardless of how many number of switches you are using in your VTP domain. So drawback wise or disadvantage, if you were saying, of VTP, the disadvantage is coming from the perspective of proprietary. This is Cisco proprietary protocol. Cisco has developed this protocol at the layer 2 level to work with the VLAN database informations for creating VLANs dynamically in your switches. And very easy configuration what exactly you need to do. Okay, regarding VTP, only 4 commands exactly you have to type. Okay, so let me just open the notepad. So this are the full set of commands, everyone. What exactly you need to use in order to create your server, in order to create your transparent client and all these things. Okay, so this is your configuration. Nice. This is switch number 1, transparent switch configuration. Enable config T. These are your trunk ports. You can see this port and this port. These two ports are configured as trunk. Then we are having our VTP configuration. It starts from here. So this command is to set up the domain. Then we are running the VTP version 2. The transparent mode, what we are configuring, and the password, what we are configuring. Okay. So all these particular set of commands is basically related to VTP. Only 4 commands, nothing else. But making sure that you have trunk links configured, always use show interface trunk command. Always verify that whether your interfaces are trunking or not. So this is when you use show interface trunk. Okay, now this command is mandatory in order to verify that which particular interface is trunking, which one is not. And trunk configuration, we have seen it yesterday, how to basically do it. If you are configuring trunk links on your layer 2 switch, then you simply just say switch port mode trunk. If you are uh, doing the same configuration in your multi-layer switch, then you have to give another command, which is to set up the encapsulation protocol, switch port rank encapsulation dot one. This is what exactly the command what you use in order to configure trunk links in a multi-layer switch. So if I scroll down towards the VTP client configuration, you can see that we have the same configuration. We're configuring these two links first, 0/4 and 0/5. So 4 and 5 is getting configured as trunk. Then we have set up the domain. The domain name is my domain and the password is my password. You can see that the VTP version 2 VTP mode client. So command wise, there is no change, everyone. You can see the same set of commands we are doing over here, the same set. Okay, these three commands always is same. The change is over here. Okay, in the VTP mode. You can see in the VTP mode, we are having transparent over here this client, because we are configuring the switch number 2 as a client switch. Okay. So configuration wise, there is no change. Only 4 sets of commands what exactly you need to configure in order to perform VTP configuration. Then we are coming to the server switch, and server switch is all about configuring these two ports 0/1 and 0/6 as trunk ports. Then we are configuring the domain, which is my domain, the configuring the password. That is my password, the running VTP version 2, and VTP mode is the server. That's it. Now, this particular command, what exactly we are using, it is to save the configuration. Okay, it is to save configurations. So whatever configuration you do on your router, on your switch, you can basically save all these configurations. Okay, by using this command, copy running config and startup config. Basically, this is file which exists in Cisco routers and switches, and this is another file which exists in your Cisco router and switches. Okay. So running config means whatever configuration which is running on your switches currently. Okay, it means temporary configuration. Okay, means when I'm configuring VLANs, when I'm configuring routing, all these configurations, if I'm not saving it, it is basically running from the running configuration. Okay, whatever you do, if it is not saved, it is basically running from this file, which is temporary. Okay, temporary. So temporarily it is running from this file. Okay, means if I shut down this switch, or if I power off this switch, for example, then all these configurations, what exactly is running on the switch, it is deleted, it is removed. Okay, that is why we are saying temporary configuration. But startup configuration, it is like what? Permanent configuration. Means whatever informations we have in a switch, if we are saving it, it basically gets stored permanently in this particular, say, like the startup configuration file. And this is the startup configuration file which is used in order to load the configurations on your router or switches. Okay, so permanent config gets stored into the startup. Means when you save it, it gets stored in startup config. When you don't save the configuration, it is basically running temporarily from the running configuration file. Okay, so most of the time, whenever we are doing the configuration, okay, we use these commands: copy running config startup config. Basically, what we are doing with this command is we are copying all the configuration which is currently running on my switch or router to the permanent configuration file, which will be saved in the router or switches, so that even if I restart my router, or even if I like what reboot my device, all the configurations are not lost. In the running configuration, it is lost, but in the startup config, it is not lost. Okay, all those configurations, it is still available. Okay, over here. So always, whenever you do the configuration, make sure that you use the commands There is a graphical way to save your configuration. This is a CLI way. Graphical way to config, okay, to save your configuration is going to configure hitting this save button over here. When you hit the save button, all the configurations which is configured on your switches or routers, it is getting saved. But this one is available in the packet tracer. Okay. In the GUI, you get a save option. But in the CLI mode, we always use the copy running config startup config command in order to save the configurations what we have done on our routers and switches. So always, whenever you do any configurations on your device, make sure that you save it properly. Okay, because by saving it, you don't have to reconfigure it again when you shut down your device or reboot your device. So, what exactly we can do with all these configurations? My switches over here, these are already configured with all these configurations available. Okay, let me just verify this. So for verification purpose, we are using these two commands, that is your show VTP status and show VTP password. When you use this VTP status command, this is one exactly you don't get to see the password what you have configured for VTP. So this is the password what we have configured. This password is not shown to you when you use this command. To see the password specifically of VTP, you have to use the show VTP password command. Okay. So always these two commands have been used. Now we are going to be verifying our VTP configuration using these two commands, everyone. But remember one thing, that BTP, since it's a Cisco proprietary protocol, it is already running, okay, in your Cisco switches. So it is already running. It is already running in all Cisco switches. And the version which is running, that is your version 2. Okay. And the mode in which it is running, it is a server mode. Means by default, when you purchase any Cisco switch, this is what exactly is the mode, default mode. Okay, it is the default mode, which is the server mode. Okay, for every single switch. Default mode is the server. So every single switch, this one is also server, this one is also server. Okay. But depending on our requirements, we have to make one as a transparent, we have to make one as a client. So in this particular demonstration, we are basically having 3 different modes switches working in the domain with the same password configured, and we are trying to see that what exactly are the difference between these 3 main modes in a practical environment. So starting with the server switch, everyone, this is the command what we are going to be giving. So enable show VTP status. So as you can see that we have this particular command, show VTP status, which is giving us the version number which is running. The VTP operating mode is the server. The VTP domain name is the my domain. The VTP v2 mode is enabled. It is the version 2 mode. This information, this much information you can get it from this particular show VTP status command. But the password we cannot see over here. If you want to see the password, you have to explicitly say show VTP password, which will reveal the password what you have configured in plain text format. Plain text means in plain simple text you can read what password exactly is there. This is what we call clear text. Clear text. Clear text means it is not encrypted. Password always should be encrypted. Okay. And this password, it must be same. It is very case sensitive. The domain name is case sensitive. Okay. So password and domain name, these are very much case sensitive. So make sure that whatever case, uppercase, lowercase you are using, make sure that the same username and password in the same uppercase or lowercase you are configuring it in multiple switches. So best way to avoid like what this type of uppercase lowercase mistake is write it on a notepad. Write all these commands in a notepad and simply just copy and paste it to other switches. In that way you can avoid doing like what is case sensitive related mistakes. Okay. Write all these commands, these four commands in a particular notepad. And after that, simply just copy it and paste it to all these switches. At least the domain name and password. So how do you check the VLAN database? Because as I have already mentioned that every single switch they maintain a VLAN database. How do you check this VLAN database? This VLAN database you can check it using a very simple command called show VLAN. Okay. This is the command by which exactly you can check the VLAN informations, what exactly exists in a particular switch. Okay. So this is your VLAN information. So as you can see, we have VLAN number 1 is a default VLAN. VLAN number 2, 2005, these are also default VLANs. And we have 4 VLANs we have created. VLAN 550, 650, 750, and 850. Okay. All these VLANs status is active. And you can see that all the ports over here it by default belongs to VLAN number. So this is the VLAN number 1 where exactly you have all the ports. By default, all ports belongs to VLAN number 1. That is why exactly if you connect your machine to FS0/3 and if you connect your machine to this particular port, you can see that 0/3 is communicating to 0/2 over here because they belong to the same broadcast domain which is VLAN number 1. Okay. The switch cannot work without VLAN. Okay, make sure that you remember that. A switch cannot work without VLAN. Always it requires VLAN. Okay. So all these VLANs we have created. Okay, over here. Now since it's a server switch, as already we have done the verification and we have seen that it is working in the server mode, we can do whatever we want. We can create VLAN, we can delete VLAN, we can modify VLAN, and whatever we do on the server switch, it is applicable to other switches in the domain, except transparent switch. Because transparent switch doesn't take any update from the VTP update packet. If I go to this switch and do the same command, show VTP status and show VTP password, you can see that this is working in transfer mode, the domain name, the version 2, the password, everything is same. And if I go to client switch, and this is where exactly we are doing the same command, show VTP status and show VTP password. This is when exactly we're seeing that it is configured as client and is the same password and domain name we have configured. Okay. These things make sure that you have the same, otherwise there will be a problem. Similarly, we have the interface trunk command is there to check out which particular ports are right now trunking. 0/4 and 5 of this switch number 2, which is working in the client mode, is trunking right now. This one is 0/3 and 0/2, which will be trunking. Show interface trunk. You can see this that these 2 ports are trunking right now. And similarly, this 5 and 6, I guess. Okay, 1 and 6. It should be trunking. So show interface trunk. And this is your 2 ports, which is right now in the trunking. Okay. So first of all, what exactly I will be doing is I will delete these VLANs, what I have created over here, so that I can show you the VLANs which I am about to create over here and how it is getting dynamically sent to other switches and they're updating their database. Okay, so all this dynamic process right now we're seeing in practical. So I'm having like what 4 VLANs I have created. You can see 550, 650, 750, and 850. Okay, so this 4 VLANs I'm about to delete right now. So you say no, then VLAN 550, 650, 750, and 850. That's it. This is how exactly you delete your VLAN. Okay, so once you deleted your VLAN, then use the show VLAN command to check the VLAN database. So right now you can see this is what exactly your brand new switch VLAN database it looks like. Only 5 VLANs, only 5 VLANs, where all the ports are assigned to VLAN number 1, and these ports and the remaining VLANs they're basically used for different other technologies like FTTI, FTTI net, TMNet. All these are technologies for which these are reserved. We don't use these VLANs for our normal or for general purposes. Okay, so we are going to check over here also. If we have any VLAN created, we'll simply just delete it. This is your 850 and 659, 850 and 950. I am also going to delete this one. So now VLAN 850 and 950. That's it. And show VLAN right now. This one also looks good with the default VLAN information. Then our last switch over here. This one is show VLAN command. And here also you can see that we have default VLANs. Okay. So now what we are going to be doing is we're going to configure this 550, 650, and 750. Okay, these 3 VLANs in the server switch, and we'll see that all these VLANs, all these 3 VLANs, what we are creating in the server switch, automatically it is getting updated in the client switch, because client switch always they update the VLAN database from the update packet. Okay, so when I will create these VLANs in server switch, this update packet will be sent to the domain, and from the domain, the client switch will collect that information and it will update its VLAN database. So let's go to our switch, but before that, VLAN 550 belongs to sales department, VLAN 650 belongs to HR, and VLAN 750 belongs to tech, right? So this is what exactly is the information we need. It's saying 150, VLAN 550, name is sales department. Then VLAN 650, name is HR department, and VLAN 750, which basically belongs to the technical department. That's it. We've created 3 VLANs. Right now, if we check our VLAN database, this is one exactly you are going to see our 3 VLAN informations we have created and the status is active. Okay. So let's go to our client switch right now, because all the configurations we have done it on our server switch. Let's go to the client switch and let's do the verification to see that if we have created automatically these 3 VLANs informations, because when we did earlier the verification, we basically got only 5 VLANs information, but right now you have total 5 VLANs plus 3, so total 8 VLANs should be there. And you can always do this check using show VLAN command, and you can see that automatically these 3 VLANs informations are coming automatically. These are basically dynamically getting created. Okay, so dynamically created with VTB. Okay. So VTB is creating this particular number of VLANs over here dynamically. Okay, all this. This is what exactly saves you time, because Right now, I am having only 3 VLANs, but if I am having 300 VLANs, this is a client switch. Automatically getting those 300 VLAN information from the server switch. So we don't have to configure all those 300 number of VLANs in this particular switch again. Okay, because it consumes time. Now, this one is client switch. I simply just give show VTP status. This one is working in the client mode. You can see. Okay. So client switch always they get the VTP update informations from the domain and they always update the VLAN database. However, it is not the same case for your transparent switch. If I check the transparent switch VLAN database, you will see that those 3 VLANs informations are not coming over here. Okay, so earlier it was having only 5 VLANs. Right now also it will have only 5 VLANs only. But those 3 VLANs informations will not be available. If I simply give the show VLAN command, you can see that we don't get those 3 VLANs 550, 650, and 750 over here because this switch is working in the transparent mode, and in the transparent switch always the configuration is manual. So you have to do manual configuration of all these 3 VLANs over here, manual configuration. That is why we don't take transparent switch when we need to create multiple VLANs across multiple switches, because it is again coming to the same, like what, same process where we are consuming time, because over here also we have to define all the switch, all these VLANs manually. Okay. So for example, if I try to create VLAN 550, so I will create it like this. Name is sales department. So every single thing we were doing it in a manual format. Name is HR department, and VLAN 750, that is name is technical department. But the 3 VLANs informations we are creating, and we are simply just giving show VLAN command to verify that whether this 3 VLANs has been created or not. Here you can see the result. Okay, so these 3 VLANs are created right now, but we have created it manually. Remember this. But let's configure another VLAN. Let's say if name is marketing department. Okay. Now this is a new VLAN, what I am creating. I don't have this VLAN available in my topology, but just for the purpose of demonstration only, we are checking out that if we are creating any VLAN in the transparent switch, whether this VLAN information it is getting updated in the VTP server or in the client switches. Okay, because as far as we know, the VTP update always server generates it. Okay, only your server it generates VTP update packet. Okay. Only it generates the VTP update packet. Okay. Other switches like transparent or client, they cannot generate this update packet. So if we cannot generate the update packet, then there is no way by which you can send this VLAN information what you have created. In our case, that is your VLAN 850 to this domain so that other users can like what update their VLAN database from this. So let's do the verification over here to find out. This is your show VLAN command, and you can see that this particular switch doesn't have this VLAN 850. Okay, so this information is not available. Similar in the client switch also, if I check it over here also, you are not seeing that VLAN 850 is there. But if I check it on the transparent switch, this is a transparent one. You can see that VLAN 850 is there. Okay. So this VLAN information, it resides locally. Okay. This information is local to your switch number 1. only. Okay, so this configuration is local to switch 1 only. Means this configuration is not getting sent as a VTP update packet, okay, or in the VTP update packet to other switches. Because transparent switch or client switch, they don't have capacity to generate this update packet. That is why it stays locally within the switch and never gets sent to other switches in the domain. Okay. So how do you do this type of modification? The question is modification. What is modification? We're saying that we can create, we can modify. Creating VLAN, you have done it. Deleting VLAN also, you have seen how it is done. But how do you do the modification? What we are trying to simply mean, okay, what we're trying to mean when we say modify. Modification, let's say that like what? You have treated your VLAN over here. So you can see that we have typed all these things in lowercase, but it should have been in the uppercase, let's say. Okay. Or maybe you want to change the name of the VLAN, for example. Okay. So this is what we are considering as modification. Okay, so what exactly you do, you say VLAN 550, and now we are going to change the VLAN name from lowercase to uppercase, that is your sales department. Then VLAN 5650, that is name is HR department. This is what we are modifying, we're changing. VLAN 750, name is tech. So this modification right now, what exactly I have done? I have done it on the server switch. Remember, switch 3 is a server. You can always use a command to verify that this is a server switch where we're doing all the configuration. And if we know about functionality of BTP server switch, then every single configuration what we are doing, it will be reflected to the client switch automatically. So right now it is time to verify, and you can see that this is a change which has happened over here. Now let's go to the client switch and let's see the same thing, the same changes has happened automatically or not. As you can see, all these are in a lowercase. So right now let's check the VLAN. And can you see automatically the change has happened? This is what we are doing modification. Okay. Now, what about a client switch? Can a client create a VLAN? Can a client delete a VLAN? Let's say I want to delete a VLAN. Let's say I don't want VLAN number 750. What message you are getting? VTP VLAN configuration is not allowed when a device is in client mode. Let's try to create a VLAN. Let's say VLAN number 750. You can see again the same error is coming. Okay. Because VTP is not allowing you to create any VLAN because the functionality of the client switch doesn't itself allow the VTP to create, to modify, to delete anything, because solely it is dependent on the server switch to get this VTP update informations about the VLANs. Okay. So whatever VTP server is sending, the client is receiving it through VTP update packet, and it is updating its VLAN database information from that. Okay. This is what exactly you are having the VTP concept, everyone. Always, this is coming um, as a time saver. Okay, as a time saver when we are having multiple number of switches, we need to configure lots of configurations of VLANs in all those switches. Okay, maybe we have less number of switches but more number of VLANs, or maybe we have more number of VLANs and less number of switches. In both these cases, VTP always is working good. Okay, it is working perfectly because at the very minimum amount of time you can create your VLANs. Okay, you can perform the VLAN configurations like what, with lower time consumption, you can say. Okay, so time consumption is the main factor over here. Okay, so all of you got it right.
But sir, anyhow, for the other configuration like the like port one and assigning wheel,
I'm saying creating.
only creating this.
Creating.
Yeah.
The way you create your VLAN. This is what exactly you are making it dynamic. I'm not saying assigning.
Yeah, yeah. For that, we have to
Assigning,
go to particular switch.
that configuration you have to do.
Yes.
Because how come your VTP will know that which port you want to configure in VLAN 550?
Yes, sir.
VTP doesn't have that kind of intelligence to automatically figure out that, okay, you have a server, so it belongs to 750. So
Yes.
this thing is not like, but it's not available. Okay, it is like what it will be in future. Right now I cannot say, but in future, if artificial intelligence is applied, okay,
Onto
then
the switches.
maybe BTP will automatically detect that which particular server is in which VLAN. Okay, with the help of AI, we can basically get this type of VLAN assignment also in future. But right now, as for now, Cisco has basically made this particular BTP available for you as a network admin, as a network engineer, to configure it on the switches in which you want to create multiple number of VLANs. Okay, at a very significant less amount of time. This is what exactly this concept is. Everyone got it? All of you?
Yes, sir.
Yes, sir.
Yes, sir.
Any is there? Any?
Yes, sir.
Understood?
Yes, sir.
Okay. Okay, everyone. So these are the configurations. Okay, screenshot. You can take the screenshot. Go on.
Done, sir.
Down Windows.
Taken.
Yes, sir.
Finished.
Yes, sir.
And this is the last configuration part.
Done, sir.
Right. Okay.
Sir, can you please show the yesterday class in screenshot? Because I'm off.
Who was Bharat?
Yes, sir. Yes.
Uh, remind me in the last 10 minutes.
Okay, bro.
Sir, on a switch maximum, how many VLANs we can create?
Maximum how many number of VLANs? Total you have 4094. 4094.
Okay.
Okay,
Okay.
it totally depends on the switch model. The newer model, the latest model, okay, of your switch, they support like more number of VLANs as well. But this type of switches, maximum to maximum 4094 VLANs you can have.
Yeah. It depends upon the port number. Yes.
Yes, it depends on the switch model itself. The operating system which you are running, that is your iOS. Over there also it is dependent. The latest iOS means what you get the more support of VLANs, more number of VLANs you can create. Okay, but the operating system which is running in this type of switches, they support up to 4094 VLANs.
Okay.
We don't need actually 4094 broadcast domains, Bhaskar.
Yes, sir.
Can you imagine? Huh? How many organization has this many number of departments? 4094 departments is there in any company.
No.
No, sir.
But Cisco has given this, okay, in future, if you are creating, okay, lots of departments, okay, in the organization, then you are basically doing it. But even 1000 also is like what 500 million is also much more, okay, because in the organization you have very limited number of departments, okay, 10 10 number of departments or 15 number of department is like a very less number. Anyways, The next thing what we are discussing is this particular protocol, everyone. Very important thing. Now, this is one of the most important concept of your CCNA switching. What exactly is it? Spanning tree protocol. What happens, see that we are having the same type of topology with some modifications, some alterations. Okay. We're using the base 3 switches topology. Okay. But this time we are having a router also getting included in the topology, that is your gateway. We have one laptop 5 getting connected to switch number 4. So this is your laptop 5. We have laptop 2, 3, and 4 getting connected to switch number 5. We have PC 2, 3, and 4 getting connected to switch number 6. So this is your switch 5. And this one is your switch 6. Switch 6. And we have internal connection coming in to the gateway. Gateway is providing access to all clients to access internet. It's a typical type of topology, what exactly we have in any organization when we are communicating to internet. Okay. The thing is, what exactly is this? What is this? STP. Why we are having it? What is the benefit of using STP in your switching network? See, the thing is, when we connect our switches together, as you can see, the switch number 4 is connected to switch 5 over this link. Switch 5 is connected to switch 6 over this link. And switch 6 is connected to switch 4 over this link. When you are connecting all these over this type of links, okay, with each other, then there is a 99% possibility that something called a loop will occur in this type of connection between switches. A loop. Loop means any frame what you are sending. Let's say you are sending a broadcast frame from this machine. From this machine, when you send a broadcast frame, most of the time this type of loops it happens when you try to send a broadcast frame. Broadcast frame means the frame's MAC address, which is set to F. The broadcast MAC address is all is F. This is the highest. All the values of your MAC address is set to F. This is what we call as broadcast MAC address, because F is representing 15, and this is the highest value in hexadecimal. So these values always are like this in a broadcast. Okay, destination. Always the destination MAC address is this in a broadcast frame, and this type of frame is getting processed by switches in a different manner. Okay. Always switches, they process the broadcast frames in a different perspective. Okay, what exactly they do is when this laptop 4 is sending a broadcast frame to this, then it comes to this port 0/17 to the switch, and when the switch receives this frame and finds out that it is having a broadcast MAC address in the destination, immediately via all the ports, it basically sends it in this way. Okay. So these two machines are getting it. This switch is getting it in this direction. This switch is getting it in this direction. When these two switches receive this broadcast frame, then they send it to this machine, they send it to this machine, they send it in this direction. Okay. And multiple broadcast frames are getting generated right now. Okay. Because broadcast means whatever, one to all. Okay. Means when you are sending a broadcast frame and some switch is receiving it, whatever ports it is connected to. Okay. Means if I speak from the perspective of switch 4 is connected to switch 5 by this port. So when the broadcast stream is coming over here, it will send it via this port to this machine, this port to this machine, and in this way it is coming as well over here. So you can see how many broadcast frames you are generating. Okay, you are generating so many number of broadcast frames over here. Okay, from one single broadcast frame, 3 broadcast frames are getting generated. Similarly, this switch again it's generating broadcast frames. Okay, so over here also it is delivering it in all these 3 machines. Then in this direction also it is sending it. In this direction also it is sending it. This is what exactly we are calling as loop. Because a frame which doesn't have any destination, it keeps on circling around the network like this. It is circling like this. This is what we are calling as loop. Now, this type of loops are not good for your switching network because it consumes the bandwidth of the link. All these are links, and links always they have bandwidth. That is your speed. 100 Mbps is the speed what we get when we use say fast Ethernet link. As you can see, fast Ethernet. All these are your fast Ethernet ports. Okay, and they have a 100 Mbps speed. Means at the rate of 100 MB per second, you are doing the transmission, you are doing the reception of the data. This is what exactly you are getting. So what exactly needs to be done to prevent these loops? Because if we are having lots of switches, it will create so many number of broadcast frames that ultimately consumes bandwidth at a much higher rate. Because if I need to send a frame by this link, I need bandwidth, I need the speed. Okay, this is the bandwidth which is basically allowing my frame to be transmitted via this particular link to this particular switch. Okay, so without bandwidth, nothing is moving. Okay, if your links doesn't have any bandwidth, your frame is not moving from this side to this side. Okay, so always to move a particular packet or a frame from one side of the link to another side, always this bandwidth is required. Okay, so without bandwidth, we never get our frames from one side to the other side of the link. So what exactly we can do to prevent this loop? This is one exactly we're having the STP concept, everyone. This is the protocol which is working at the layer 2 level, that is your data link layer level, to prevent the loops. Okay, to prevent. So it will not allow any type of loop to happen. You can see one of the port is orange. Now this port is orange means it is blocked. Okay. What STP is doing, it is blocking one of the port so that if anything comes in this direction, it gets blocked over here. And if anything needs to be sent from this direction, then also it gets blocked over here. Means this port is not receiving any type of frame which is getting sent in this direction. Okay, or maybe it wants to come from this direction, it is not getting sent. Okay, so nothing is received, nothing has been sent. This is what exactly you are having STP. Okay, the main base concept is. So by blocking one of the port, what exactly is achieved? Communication in one direction is achieved. Like this. Like this. Okay, because when we unblock this port, communication can also happen in this direction, and this basically creates a loop, as you can see. That is why we don't want to like what create loops over here by unblocking the port. That is why the STP always blocks this. Now this one automatically is done. It is, you can see that I haven't done any like what configuration at all. This port is getting blocked. Okay, if you want to see it in practical, let's take this for example. Let's say that we have one switch over here and the switch over here, and if I connect this particular port to this port, if I connect this port to this port, you can see that it is taking some time. Okay, so just wait. So right now you can see both ports are green, right? Both ports are green. Means these ports can receive and send data frame without any problem. Because right now no loop exists. Okay, switch basically is having a mechanism, and the mechanism says that when you transmit a frame via, okay, let's say that this switch wants to transmit a data frame. Okay, it is transmitting this data frame via this FS0/1 port to this switch. Okay, to this switch. Then the port, what exactly it is using, that is your 0/1 to transmit this data frame. The same port cannot be used to receive the same data frame over here. Okay. In other words, if the same data frame is coming back to this particular port, this switch will not receive it. The same thing. Okay. Means whatever you are sending to this switch 7, if switch 7 also sends back the same thing back to you. Okay, because you are the originator. When you are transmitting the frame, you are the originator who has originated this data frame and transmitted via FS0/1. And when this particular frame gets sent over this link via this port FS0/1, then the same port cannot be used to receive the same frame which you have originated. This is basically a rule in terms of switch frame forwarding. Okay. A switch cannot receive the same frame what exactly it has transmitted to other switch over a particular port. Okay. And that is the reason you are not seeing any of this particular port is orange. But if I add another link in between these two switches, now let's say 3 is getting connected to 4. Now there is a possibility. Okay, and the possibility is huge because we have multiple links now. Okay, so you can see clearly that these, if I use this port to transmit my data frame, then in this way, it can basically go to this particular port, and there is a possibility that in this way, it can again come back to FS0/2. Now, this is one exactly you can see that this port is getting orange right now, it is getting blocked. Okay, see that STP is already working. It is STP is already running. It's already running. So you don't have to do anything. First of all, you have to understand that why this port is orange, why this port is not orange, why this switch is having a block port, why not this switch is having a block port. How this STP is taking its decision to block one of the ports of a certain switch. What is the concept? What is the logic behind STP blocking or allowing certain frame over a certain port? This is what exactly you have to understand. Okay, because this is one of the main concept of switch network. Okay, a very important concept. So this is what we are going to be explaining over here. If I connect any other link, let's say I'm connecting 0/4 to 5. Now you will see that multiple links are getting blocked over here. Multiple links. So this one is already blocked. This one is already blocked. You will see that this one is also getting blocked. So 2 ports will be blocked. And you can see that this is the same thing which has happened. 2 ports are right now blocked. Okay. So communication is going in this way. Okay, and in this way. That's it. Whatever frame you are sending, this port on this switch is receiving it. But if the switch is sending the same frame back to this switch, then this switch will not be able to receive it, and it prevents the loop in this manner. So how
And
this
sir,
tell me.
and sir, what about that the switch switch 7 will send back the frame onto the FA02 only from FA02 from the same port which I will.
It can use any of these ports. Okay, this switch,
Yeah.
whether it is using this one or this one FS0/4 or FS0/5. It doesn't matter. Whatever ports it is like but using to send the frame. The thing is, when the frame is coming in this direction over here, it is getting blocked. And it prevents the loop because we're talking about same frame. Okay. We're talking about same frame getting sent or received. So whatever frame we are sending, if this switch is also sending back us the same frame, okay, such as in broadcast, it happens, right? If this machine is sending a broadcast frame, then this broadcast frame is going via this particular link over here, and via this port again it is coming back, right? Because it's a broadcast. So in this case, the problem comes in. Okay, the problem of loop comes in. Okay. So neither of these 2 ports will be able to send or receive any data from it. Okay, because they are blocked.
And so suppose if there is only one link, suppose, and a broadcast frame will be sent from switch 0.
It will not be, because in one link, no loop will occur. No loop can happen. Okay. If I simply delete any of these links, okay, let's say I delete this link, there will not be any block port. Why there will not be any block port? Because as I have already explained this one, that when suppose this machine is sending a broadcast, it is sending a broadcast frame.
Okay.
If this machine is sending a broadcast frame to this machine, then this is the port what exactly it is using to transmit this information, right?
Yes, sir.
Yes or no?
Yes,
And
sir.
this switch is receiving it over here, right?
Okay,
Yes or
okay.
no?
Yes.
So
Now it will forward it to the remaining switches of.
yes. So
Yeah.
this port is the port where it is receiving this broadcast frame. So switch cannot use the same port to transmit back the same frame what they have received on a particular port.
Okay.
Okay. This switch cannot use the same port again to transmit the broadcast frame back to switch 0 by the same port, because whatever frame you are receiving, on this port. You cannot use that same port to transmit back the same frame what you have received over here. Understood?
Got it, sir.
This is the reason you are not seeing any orange port in a single link. Okay, always. So the question is how exactly all these things happen. So these are the three election process, everyone, which you need to understand: root bridge election, root port election, and designated port election. This is how exactly your STP works. First of all, we're going to be discussing about root bridge election. Okay, root bridge is basically considered as the main switch, main switch, main switch. Okay, we're having three switches over here. But among all these three switches, which switch forwards every single traffic of these particular machines to internet? Which switch forwards every single machine's traffic to internet?
Switch 4.
Switch number 4, right?
Yes.
Because anyone who wants to go to internet, they are going via who? Via this switch, right? Yes or no?
Yes.
From here also they are coming via switch. From here also they are going via switch, right? This is the main switch, right? This is the central switch. Okay, we call it centralized switch or the main switch, or in STP terms, it is called root bridge or root switch. Okay. So this root bridge election, it basically happens with the bridge ID, everyone. Every single switch, they have a bridge ID, which basically we have two types, normal and extended. Normal bridge ID consists of bridge priority and the switch's MAC address. And extended bridge ID contains priority, MAC address, and the VLAN ID information. These are the parameters. What exactly is there in normal and extended bridge ID? So always priority. Okay. Always priority of your switch, it is 32768. This is what exactly the bridge priority is. In every single Cisco switch, you get a bridge priority of 32768. And this priority always is coming as one of the criteria for your root bridge election. Okay. Lowest switch bridge ID. This is what exactly you are having the criteria. Okay. If any switch having the lowest bridge ID, which is priority and MAC address, if this switch is having lowest priority, let's say it is 32767, then this one is 768, this one is 768, but this one is 767, it will be the root bridge. Because this is coming as first criteria. But if the priority is equal, in our case, all this priority is equal. This is one exactly the MAC address comes in picture. Okay, so this is the MAC address of the switches, which is basically the VLAN 1 MAC address. VLAN 1. Okay, that is your interface VLAN 1 MAC address. Because VLAN 1 is the default VLAN which exists in every single switch, and this is your interface VLAN 1 or layer 3 VLAN 1 interface MAC address, which is basically taken into consideration for this root bridge election. Let me just show you this. Can you see the VLAN 1 MAC address at the very last?
Yes, sir.
Yes.
What is the MAC address?
0080.
0003, then E412, then
DC2B.
then this particular switch MAC address. Is it the same MAC address what we have over here? Is it the same MAC address what you have seen just now?
Yes, sir. Yes.
Yes, sir.
Okay. Then compare this MAC address over here. What is the MAC address of this VLAN 1?
Yes, sir. 0040.
0040.0 B37.E097.
Okay. Is it the same MAC address on the left side you are saying?
Yes, sir.
Yes, sir.
This one is same, right?
Yes, sir.
And similarly over here.
Yes, sir. 00 B0 dot
Yes,
5HCE dot 5E66.
Is it the same MAC address on the right side you were saying?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so now you know that from where exactly this MAC address is coming, right? This is your VLAN 1 MAC address, which is taken into consideration for the root bridge election. Okay, so what exactly we are doing over here is we are comparing. Okay, all these values are getting compared with each other. So this switch is comparing these two switches. Okay, MAC address. Similarly, this switch is comparing these two switches MAC address, and this switch is comparing these two switches MAC address. Every single switch is comparing each other's MAC addresses to find out that which particular switch MAC address is the lowest. Okay, which switch's MAC address is the lowest. So value by value they are calculating. So first value is what? 0, right? The first value over here is 0.
0.
And the first value over here is 0. So it's a tie, right? It's a equal. Then we have the second value is what? 0.
0.
Second value
0.
is 0. And again second value is 0. Again tie. Then in the third value we are getting what? 0. In the third value over here we are getting what? 4.
So
And over here we are getting what?
D.
D. So D means what? D means
13.
hexadecimal D, that is in decimal we are having what? 13, which is bigger
Yes,
than
sir.
these values, right?
Yes, sir.
Yes or no? So which one is having the lowest value in the third position?
Switch 4.
Right? That is
Switch
why
4.
switch 4 is the root page. Okay. That is why this particular switch is the root page. We call it a root switch. Okay. Now, this is coming over here as a criteria. Okay, lowest priority, lowest MAC address. This is what exactly is the criteria. Okay. Now, the next election, what we have is a root port election. Okay, so this root port election basically takes place in non-root switches. So this is one non-root switch. This is another non-root switch. So these two switches, what exactly they will try to do is they will try the best path to connect to the root bridge, because this is the main switch. All the non-root switches, they will try to connect to the root bridge via their ports. Which port they should use to connect to the root bridge? This port or this port? Whether this switch should use this port to connect to the root bridge or this port. This is what exactly the election, what we are referring over here as root port election. Okay. Root port election always happens in non-root switches. Remember this. Non-root switches always they try to connect to the root bridge via the root port. Now from this particular diagram, you can see that this one is a root port, this one is a root port. Okay. But how come this one is coming as a root port? This is why exactly you have to understand this particular calculation, which basically based on speed. The root port election always happens based on speed. Okay, we have the speed of the link to connect okay to the root bridge. So 10 Mbps, 100, 100 Mbps, 19,000 Mbps, 4, 10,000 Mbps. These are cost, what always is taken into consideration when we are selecting the root port in a non-root switch. These ports are basically coming from the type of the speed is coming from the type of the ports what we are using, like Ethernet. If we are using an Ethernet port, okay, then we get 10 Mbps speed. If we are using fast Ethernet, then we get 100 Mbps, then we have gigabit Ethernet. Then we get 1000 Mbps and we have 10 gigabit Ethernet port, then we get 10,000 Mbps. This is what exactly you are getting. Based on the type of the ports, you are getting the speed. And based on the speed, you are getting the cost. This is the cost, what exactly we are using. As you can see, everywhere we are using FA. Okay, all this FA. FM is what? Fast Ethernet. And this is where you are getting the speed of 100 Mbps. And the cost is coming over here is 90. So every single non-root switches, they're calculating that which port exactly they should use to connect to the root bridge. So they're calculating the cost in this manner. So this switch is calculating that whether it should use 0/1 or 0/6 to connect to the root bridge. So it is calculating the cost of 0/1. The cost is what? 19, right? To reach the root bridge? Yes or no?
Yes, sir. 19, yes, sir.
19. But if it is using 0/6, then the cost is what? 19.
38.
Then from 19 over here, right? The
Yes,
total
sir.
cost is coming 38. In which port? In this port. And 19 is coming in this port. Now, which one is the lowest?
19.
19.
0/1, yes.
That is why this one is the root port. Similarly, this switch is deciding that whether this port or this port should be root port. So this is one exactly it is checking the cost. So from here to here, the cost is what? 19. And if it is using this port, then cost is 19, then 19. So total is what? 19 plus 19, that is your 38, which is higher, right, on this port. So
Yes, sir.
which one is the root port? This one. Okay. This 0/4. So depending on the cost, okay, depending on the cost, it is getting decided that which port should be the root port. Okay. And at last we have the designated port election. This is the last port election, and this selection basically says that which port should be blocked. Okay, because since we are using STP, one of the port will be blocked. You can see that this port is getting blocked over here. This 0/5 port. Why this port is blocked? Why not this port is blocked? This is what we need to understand. So for designated port election criteria, the same criteria is there. Okay, the speed cost criteria. So first of all, this port, okay, this switch will be calculating that what is the cost it is getting by FS0/6 to reach the root bridge. The total cost is what? 38, right? Yes or no?
Yes, sir.
On this port. Similarly, this switch will check that what is the port it is getting via this way to reach. So it is also getting what? 38.
38.
Right? So both cost is equal. At the time, what exactly we are using, that is our bridge priority. Okay, so bridge priority and MAC address we are using to find out this. So this is coming whenever we have the same cost to reach the root bridge. This priority, we are comparing the priority of these two switches. So priority wise it is equal. MAC address wise, we can see that in the third value we have a loss. Okay, we have a lower value, right?
Yes, sir.
Compared to this one, which is like what, a higher value. So based on this, we are coming to the conclusion that which port will be blocked, because higher is not preferred in STP. Always lowest is preferred. Okay. Whether it is your priority, whether it is your MAC address, whether it is your cost, everything is lowest is preferred. Okay. So the side which is having highest or higher MAC address, this side is getting what? Blocked, and this particular port, that's what? That is rejected. Okay. So designated port means what? The port can send, receive frames, informations without any problem. But blocked port means what? The port cannot send or receive anything. Okay. So specifically the data frame we're talking about. Now, got this particular thing, everyone, this election process,
Yes, sir.
everyone got it?
Sir, can you open the switch one, switch 5? I want to just take the screenshot of for the MAC address.
Switch 5, okay.
Okay, sir. Done.
Okay. So now what exactly we are going to be discussing, this is your timer setting. Okay. You can see that this port is blocked right now. If I simply just delete this link, now you will see that this port will be unblocked. Okay, it is getting unblocked now automatically. Okay, so it will be unblocked means this port will be clean. But you can see it is taking some time to unblock it. Okay, now this time is basically defined over here in STP timers. Okay. So what exactly are this? This is what we have: hello timer, forward delay timer, maxis timer. Okay, basically this is the packet what exactly we use to perform the election process. All this root page, root port, designated port, election, all these things, it happens based on this STP packet. So this is the STP packet called Bridge Protocol Data Unit. In short, we call it BPTU. Via this packet only, switches, they get to know about the priority, about the MAC address, about the cost, every single thing. This is the packet which is exchanged between switches in order to basically make the election process, okay, to like what to happen. Okay, so always this packet is being used. This is the timer. In every 2 seconds, this packet is being sent, okay, by root bridge to all the switches, okay, in the domain. This is the hello timer, 2 seconds. These are the port states. Okay, you can see that this port is right now unblocked. So how much time exactly it is taking to unblock this port? Okay, this much what exactly we are having over here. Okay, so for disabled means what, the port is shut down. The port is shut down. Okay, if the port is shut down means what? It cannot do anything. Okay, blocked means either this port was blocked, but right now it is unblocked. Okay, it is unblocked. So how much time exactly we have waited for this port to be getting unblocked? This is what exactly we're having. The maxis timer is there. You can see the maxis timer. So from here to here, okay, it was taking 20 seconds of time. 20 seconds. Okay, from disabled to listening. 20 seconds of time was there. And from listening to learning, okay, from listening to learning and learning to forwarding. In both cases, we're having 15 seconds of time. So 15 seconds we are taking to move from listening to learning, and from learning to forwarding, we are taking 15 seconds. Total 15 plus 15 plus blocked, that is your blocking to unblocking, that is your 20 seconds. So total 20 plus 15 plus 15. How many seconds? 50 seconds, right? Total 50 seconds. A particular port has to wait before it moves towards the forwarding. Forwarding means what? The port can send receive informations. Okay, can send frame, can receive frame, okay, without any problem. So unless the port is in the forwarding state, you cannot send or receive frames via the port. Okay, so always 50 seconds of time you have to wait. Okay, for example, if I again connect this link between these two switches, so this is your 0/3 starting connected to 0/4 over here. So you can see that this port is again going to orange. So this port again it is getting blocked. Okay, but you can see the amount of time you are taking. So 50 seconds total. Okay, you are waiting. After that, this particular port it will be going to the forwarding state. That is the green state. Okay. So this much amount of time is okay, what you have to wait in order for the port to basically getting in the forwarding state. Okay, so all of you simply just take a screenshot of this. You guys have taken this part All of you? This part you have taken, right?
Yes.
This part you have taken?
Yes, sir.
Taken, right? Okay. This is the part. Got it?
Yes, sir.
Yes, sir.
Okay. So we'll see in the next session that what exactly we can do with STP. Okay, there are not much things you can do, just 2-3 commands you can basically run in STP. Other than everything is automated, everything is automatic only. Dynamically, ports are getting blocked, it is getting unblocked. So we as a network admin, we don't have to do so much configurations in STP. Okay. So whatever we can do, I will show you in the next session. And our next session concept is cabling at one. The cabling, this is the last concept, what exactly is pending. And most probably tomorrow you are having the last session as well. Okay, if we cover all this in the cabling. Okay, so just wait. Let me just take the screenshot.
Sir, yesterday's class.
Yesterday's here. Just hold on.
Yes.
Okay. Yesterday we have done the VLAN configuration. So, take this screenshot.
Okay, sir. Done, sir.
Take this.
Done, sir.
Taken.
Yes, sir.
Yes,
Done.
Taken.
Yes, sir.
This is our VLAN configuration. We have done it. Take it.
Yes, sir. Done.
Taken, right? Okay. This part.
Yes, sir.
This part.
Done, sir.
Yes, sir.
Okay. That's it.
Thank you, sir.
Okay. So all of you, I will see you guys in the next session. Okay. Bye and take care, everyone.
Thank you, sir.
Thank you, sir. Bye.
Sir, excuse me.
Tell me
Sir, last one.
which one?
Means last configuration, last slide.
Configuration.
Yes.
VTP.
VIP FTP. Yes.
This one.
No. That previous one you showed earlier.
Okay. That is a VTP configuration, nothing
Yes, sir.
else. This is what you have done today, right?
Okay, sir.
This is this configuration only. Here is the full configuration. And over here you have the certain
Okay, sir.
configuration of this. Okay, all of you. So I will see you guys in the next session. Okay. Bye and take care, everyone.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.